Good morning, students. Welcome to the new lecture of physics. I am Mayur Sharma, and in this lecture we are going to discuss about unsolved examples of electromagnetic waves. Basically, we are going to discuss about the unsolved examples 8.5, 8.6, 8.7 and 8.8 in this lecture. Unsolved example 8.5. A radio can tune into any station in the 7.5 MHz to 12 MHz band. What is the corresponding wavelength band? So in this example you can see that a frequency range is given from 7.5 MHz to 12 MHz and we have to measure the corresponding wavelength band. So in this example minimum frequency is given as 7.5 megahertz, so that is equal to 7.5 into 10 to the power 6 hertz, and maximum frequency is given as 12 megahertz, so that is equal to 12 into 10 to the power 6 hertz. Now, if you have gone through my previous video on electromagnetic spectrum, you will find that if wavelength increases, then frequency will decrease, and if frequency increases, then wavelength will decrease. So it means that maximum frequency will be corresponding to minimum wavelength, and minimum frequency will give you maximum wavelength. So here the relation between frequency and wavelength is C is equal to, if wavelength is minimum, lambda minimum into frequency maximum. So this implies that lambda minimum will be equal to C by F max. So that is equal to C is speed of light, that is 3 into 10 to the power 8 over F maximum is 12 into 10 to the power 6. So 3 divided by 12 will give you 0.25. 0.25 into 10 to the power 2, or you can say that this is nothing but 25 meter. This will be our minimum wavelength. Now in the same way, speed of light c will be equal to lambda maximum into frequency minimum, or therefore we can say that lambda max is equal to c over minimum frequency. So that is equal to 3 into 10 to the power 8 over 7.5 into 10 to the power 6. So 3 divided by 7.5 is 0.4. So this is 0.4 into 10 to the power 2, or you can say that 40 meter. So therefore the corresponding wavelength band will be from 25 meter to 40 meter. Unsolved example 8.6. A charged particle oscillates about its mean equilibrium position with a frequency of 10 raised to 9 Hz. What is the frequency of electromagnetic wave produced by the oscillator? So, we know that the frequency of electromagnetic wave emitted from a given source is always equal to the frequency of It is always equal to the frequency of that source. Therefore, frequency of electromagnetic wave here will be 10 raised to 9 hertz, as frequency of wave and source is always same. Unsolved example 8.7. The amplitude of the magnetic field part of a harmonic electromagnetic wave in vacuum is B naught equal to 510 nanotesla. What is the amplitude of the electric field part of the wave? So in this example, you can see that amplitude of magnetic field is given as 510 nanotesla, and we have to calculate the amplitude of electric field. So given B naught is equal to 510 nanotesla, that is equal to 510 into 10 to the power minus 9 Tesla. Now for the propagation of electromagnetic wave in vacuum, let E naught be the amplitude of electric field. So if a wave is propagating in vacuum, we have assumed that E naught is the amplitude of electric field. Now we know that the relation between electric field and magnetic field is C is equal to E naught over B naught. So this implies that E naught will be equal to C into B naught. So therefore E naught will be equal to C speed of light, that is 3 into 10 to the power 8, and B naught is given as 510 into 10 to the power minus 9. So 3 into 510 is 1530 into 10 to the power minus 1, or you can say that 153 volt per meter. This will be the amplitude of electric field. Unsolved example 8.8. Suppose that the electric field amplitude of an electromagnetic wave is E naught equal to 120 Newton per coulomb and that its frequency is 50 megahertz. A. Determine B naught, omega, K and lambda. B. Find expression for E and B. So in this example, amplitude of electric field is given as 120 Newton per coulomb and frequency of electromagnetic wave is given as 50 megahertz. We have to find the value of amplitude of magnetic field B naught, wavelength lambda, wave vector K and angular frequency omega. Also, we have to find the expression for electric field and magnetic field. So let us start solving this example by making list of given data. In this example, amplitude of electric field E naught is given as 120 Newton per coulomb and frequency of electromagnetic wave is given as 50 megahertz. So that is equal to 50 into 10 to the power 6 hertz. A. In that first one, we have to find the value of B naught. B naught is amplitude of magnetic field. Now, for a wave, for an electromagnetic wave, propagating in vacuum, we have C is equal to E naught over B naught. This implies that B naught will be equal to E naught by C. So therefore, B naught will be equal to E naught is given as 120 and speed of light c is 3 into 10 to the power 8. So 120 by 3 is 40 into 10 to the power minus 8, or you can say that amplitude of magnetic field B naught will be equal to 4 into 10 to the power minus 7 Tesla. This will be the amplitude of magnetic field. Second one, angular frequency omega. We know that omega is 2 pi f. So that will be equal to 2 into 3.14 into 50 into 10 to the power 6. So 2 into 3.14 into 50 will give you 314. So therefore omega will be equal to 314 into 10 to the power 6 radian per second, or you can write this as 3.14 into 10 to the power 8 radian per second. Third one, wavelength. Lambda. So we know that C is equal to lambda f. So this implies that lambda will be equal to C by f. Speed of light c is 3 into 10 to the power 8 over frequency is given as 50 megahertz. So 50 into 10 to the power 6. So 3 divided by 50 will give us 0.06. So this is 0.06 into 10 to the power 2 meter, or you can say that wavelength is 6 meter. And fourth one is wave vector k. For wave vector we know that k is equal to 2 pi by lambda. So that is equal to 2 into 3.14 over 6. So 2 divided by 3.2 into 2 into 3.14 divided by 6 will give you 1.0466, or you can write nearly equal to 1.047 radian per meter. This will be the value of wave vector. Now B, we have to find the value of, we have to find the equation for electric field and magnetic field. Let us assume that let the given electromagnetic wave be propagating along positive x-axis, and its electric field and magnetic field be along y axis and z axis respectively. So we have assumed that this electromagnetic wave is propagating along positive x-axis and electric field is along y-axis and magnetic field is along z-axis. Now the equation for electric field is E is equal to E naught sine kx minus omega t j cap, because we have assumed that it is traveling along x-axis and electric field is along y-axis. So E naught is 120 sine k we got as 1.047 x minus omega is 3.14 into 10 to the power 8 t j cap volt per meter, or you can write Newton per coulomb. This will be the value of electric field, and magnetic field B vector will be equal to B naught sine kx minus omega t. So that will be equal to B naught is 4 into 10 to the power minus 7 sine k is 1.047 x minus 3.14 into 10 to the power 8 t k cap Tesla. This will be the value of magnetic field.